Hi guys! Welcome to my video. I am Precious Soap Magway and I'm gonna be showing and explaining Boyle's, Charles, and Gay-Lussac's law. So now, we're starting our three-part series of Law of Gases. Today's episode, Boyle's Law. Boyle's law states that in a closed system, the volume and pressure are inversely proportional. What that means is, when pressure increases, the volume decreases, or vice versa. The only equipment that we're gonna be needing is a large syringe that you can buy from a drugstore and a balloon. Although we are not dealing with any sharp materials, we need to wear safety gears like lab coat or gloves. First thing you're gonna do is blow your balloon. Make sure it is fit to the syringe. After this, light it up and get your syringe. Next, place your balloon to the syringe. And we're ready.
The balloons and syringe are filled with tons of gaseous molecules. Placing the finger on the opening of the syringe leaves the mass of the air molecules constant, creates an enclosed system that allows us to manipulate the pressure and volume. When we push the plunger down, we're increasing the pressure being placed on the air molecules inside the syringe by reducing its volume. As pressure increases, amount of force placed on the air molecules increases and forced to close together, decreasing the volume of space that gas takes up. When we remove our finger from the balloon, we release the pressure and the balloon go back to its original volume. For the second part of our experiment, we start the plunger at the bottom of our syringe. When the plunger is pulled upward, we're reducing the pressure inside the syringe by increasing the volume of the balloon. This increasing volume and decreasing pressure holds the air molecule further apart, increasing the amount of space that gas takes up. Removing your finger from the syringe returns the pressure back to normal, reducing the volume and size of the balloon.
And that's it for Boyle's law. For the second part of series of law of gases, Charles' law. Charles' law states that in a closed system, the temperature and volume increases proportionally. That means when the temperature increases, the volume increases too and vice versa. The equipment that you're gonna be needing is a balloon, a hot water, a refrigerator, and gloves. For the safetiness, you need to wear a gloves because you're dealing with a hot water and a lab coat.
Our balloon is filled with gaseous air molecules. When the balloon is placed in the glass with boiling water, the energy from the higher temperature water and steam molecules transfer to lower temperature air molecules inside the balloon. When the air molecules inside the balloon are excited by raising the temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature, the larger the balloon will grow. We place our balloon from the freezer for an hour, which causes to transfer energy in form of heat from the warmer air molecule inside the balloon into the cold freezer. As energy removed from air molecules, they slow down, drop in temperature, and get closer together. The colder the air molecules get, the closer together they will be.
And that's it for Charles' law. Third part, Gay-Lussac's law. Gay-Lussac's law states that the temperature and pressure are directly proportional. That means when the temperature increases, the pressure also increases and vice versa. The equipment that we're gonna be needing is a plate with water, a candle, a spoon, a food coloring, glass, and a match. We should also wear gloves and lab coat because we're dealing with fire. Spill a water to the plate. Add some food coloring so you will be able to see it. Then mix it. After that, place the candle to the middle.
After having a little while, you'll notice the candle flames will get smaller and smaller until it's gone. If you watch closely, you'll see that the water begins to rise. Our glass is filled with gaseous air molecules. The energy from our flames transfer to air molecules, exciting them by raising the temperature. When the air molecules from the glass excited, they try to spread apart. Because our glass won't expand like a balloon, the volume of space our air molecule can take up is limited. The higher the temperature, the more pressure will be created under our glass.
And that's it for our three-part series of law of gases: Boyle's Law, Charles' Law, and Gay-Lussac's Law. Once again, I'm Precious Hope Mahagway, and I hope you learned something today. Thank you and goodbye.